Every great ape on this planet, chimpanzees, gorillas, orangutans, is covered in thick fur from head to toe. You share over 98% of your DNA with a chimpanzee, and yet if you stood next to one, you would look almost completely bare. Science said for decades that the answer was simple. We lost our fur to stay cool. Bipedal hunters chasing prey across open savanna needed to sweat, and fur got in the way. But that explanation has a problem, a significant one. We didn't lose our hair. We redistributed it.
Right now, your body has roughly the same number of hair follicles as a chimpanzee. The same number. What changed isn't the count, it's what each follicle grows. Most of yours produce vellus hair, the fine, almost invisible strands that cover your arms, your back, your face. Short, thin, barely there. A chimpanzee's follicles produce terminal hair, thick, pigmented, full coverage.
So the real question was never, why did we lose our hair? The real question is, why did it stay exactly where it stayed? Because it did stay, prominently, stubbornly, in specific locations that don't fully make sense if cooling was the only story. Your scalp, your armpits, your groin, your eyebrows, your eyelashes. Each one of those zones has a different answer. And some of those answers are strange enough to make you look at your own body differently.
Let's start with the theory everyone knows, and why it only gets you halfway there. The thermoregulation hypothesis holds that as early Homo moved out of forest shade and into open grassland, dense fur became a liability. Running long distances in equatorial heat, covered in thick hair, would have caused fatal overheating. Losing the fur allowed sweat to evaporate directly off skin, a far more efficient cooling system. This part is well supported. Humans have between 2 and 5 million eccrine sweat glands, more than any other primate. We are, by some measures, the best endurance cooling machine in the animal kingdom. That didn't happen by accident. The loss of dense body fur and the expansion of sweat gland coverage almost certainly co-evolved. But cooling doesn't explain the pattern. If fur loss was purely thermal, you'd expect it to be uniform. Lose the fur everywhere, gain maximum cooling everywhere. Instead, you have dense hair in your armpits and groin, two of the warmest, least ventilated zones on your body. You have a full covering on your scalp, directly over the organ most vulnerable to overheating. You have eyebrows on a face that otherwise carries almost none. The distribution isn't random, but it isn't purely thermal either. Here is where the biology gets stranger. Around 1:30 into explaining this, most people expect the story to get cleaner. It gets messier. A competing hypothesis, one with serious scientific support, is called the ectoparasite hypothesis. The argument runs like this. Dense fur is a habitat. Lice, ticks, fleas, and mites live in it, breed in it, and feed through it into your bloodstream. In a social species living in close physical contact, ectoparasites spread fast and kill efficiently. They carry disease, they compromise immune function, they drain resources. Losing body fur would have reduced parasite load dramatically. Not just the discomfort, the genuine survival cost. A hairless body is harder to colonize, easier to inspect. The same social grooming behavior that exists in every primate, picking through a partner's fur, becomes far more effective when there's less fur to hide in. This hypothesis explains something the cooling theory struggles with: why hair loss appears to correlate in evolutionary timing with the expansion of social group size in early Homo. Bigger groups mean more vectors for parasite transmission, more pressure to reduce the habitat those parasites depend on. It also explains why the hair that remained tends to cluster near the face, where visual social signaling happens, and near reproductive zones. Which brings us to the part that most biology textbooks gloss over. Your armpit hair is not vestigial. It is not a leftover. It is doing something. The axillary region, your armpit, contains a high concentration of apocrine glands. These are different from the eccrine sweat glands that cool you down.
Apocrine glands produce a thicker, protein-rich secretion that interacts with bacteria on the skin surface to produce odor compounds. Specifically, compounds that carry chemical information about your immune system, your stress levels, your genetic compatibility. The hair in that region acts as a dispersal structure. It increases the surface area available for that secretion to evaporate and project into the surrounding air. Remove the hair, and you reduce dispersal efficiency. The same logic applies to groin hair. You are, in other words, equipped with a scent broadcasting system, one you cannot consciously operate, one that has been transmitting information about your biology to every person in your physical vicinity for your entire life, without you knowing it. That is not a metaphor. That is the function the hair is performing. Now look up at your scalp. Head hair is the most visually obvious anomaly in human hair distribution, and it has at least two converging explanations. The first is thermal protection. When you walk upright, your scalp is the surface most directly exposed to overhead solar radiation. The brain is the most metabolically expensive organ in your body. It generates enormous heat and is catastrophically sensitive to overheating. A thick layer of insulating hair on the scalp reduces direct solar heat load on the skull. It also traps a layer of still air that buffers against both heat and cold. Your head hair is functioning like a hat you grew. The second explanation is sexual selection. Long, healthy scalp hair is one of the most visible, honest signals of nutritional status, hormonal health, and parasite resistance available on a human body. It is difficult to fake and expensive to grow. In evolutionary terms, it became a fitness advertisement, selected for not just because it was useful, but because it was attractive to potential mates who were reading it as a health signal. Both pressures likely acted simultaneously. The result is the most prominent hair on your body, in the most visible location. Your eyebrows deserve a moment of their own. Of all the hair on your face, eyebrows are the only ones with a clear, non-contested primary function: communication. The human face is uniquely mobile. We have more facial muscles dedicated to expression than any other species. And eyebrows sit at the exact anatomical position where those expressions are most legible from a distance. A raised eyebrow signals surprise or question across 30 feet. A lowered one signals threat or concentration. The movement is fast, involuntary, and universally readable across every human culture studied. Experiments where eyebrows were digitally removed from photographs found that people had significant difficulty recognizing even famous, familiar faces. Eyebrows are a social interface. They stayed because losing them would have made you harder to read, and in a deeply social species where cooperation determines survival, being unreadable is dangerous. The full picture, then, is not one story. It is 6 overlapping ones. Body hair didn't disappear because of a single evolutionary pressure. It reorganized under several competing pressures simultaneously: cooling, parasite reduction, chemical signaling, solar protection, sexual selection, and social communication. Each zone on your body reflects a different negotiation between those forces. The vellus hair covering most of your skin? A compromise. The follicle is still there, still active, still capable of producing more, but dialed down to near invisible. A placeholder from a hairier past. The terminal hair that remains? Each patch is a record of something that mattered enough to keep. A solution to a problem your ancestors faced before language, before tools, before fire. You are not naked. You just look that way. Underneath the surface, your body is running the same hair program it has run for 2 million years. Slightly adjusted, imperfectly updated, but still executing. Every follicle on your skin is an inherited decision. Every patch of bare skin is a trade that was made, somewhere in deep time, for a reason that felt urgent enough to encode permanently into your biology. The strangest part is not that we lost most of our fur. The strangest part is how precisely we kept the rest of it.